See, this is a problem from IIT JEE 2008 based on errors. It's given students 1, 2 and 3 perform an experiment for measuring acceleration due to gravity using simple pendulum. They use different lengths of pendulum and or record time for different number of oscillations. The observations are shown in the table. Least count for length is given, least count of time is given. That means least count of length is 0.1 centimeter, that is it is measured with a vernier caliper. Okay, so this vernier caliper has a least count. That means this least count, which is equal to the least count error delta L, is 0.1 centimeter, and least count for time, that means they use a stopwatch for time where it is like this. This is second is like this. So the least count for time, that is delta T, is equal to 0.1 second. Okay, now it's given that so E1, E2, E3 are percentage errors in G. Now the equation is this: T equal to 2 pi root over of L by G. So we can write G is equal to 4 pi square L by T square. Therefore the error, so delta G by G is equal to delta L by L, because L has power 1 and T has power -2, but minus doesn't matter, so it is 2 delta T by T. So this is the percentage error, fractional error in G. See, delta G by G. Now we will calculate now in case 1, 2 and 3. Case 1, case 2 and case 3. Now case 1, this delta G by G into 100 is equal to, now delta L by L. Delta L is always 0.1 centimeter and divided by the length of pendulum in the first case is 64 centimeter plus twice delta T. See, delta T is 0.1 second. Now it is on the total time measured, not on the time period, remember that. So here, to test whether you know or don't know, it is given, I am showing it. Total time for oscillations is 128 and time period is 16. When you are measuring with the stopwatch, suppose these oscillations happen, so many oscillations happen, you are measuring at a time all these oscillations, right? So the time should be the time for all oscillations. Total time, not this. Remember that. With the stopwatch you measure 128 seconds. It is on the time measured, that delta T divided by T. Here delta T is the least count error in time and T is the time measured, not the time period. Remember that. So this is 128. Okay. Actually, to decrease this fractional error, we do the calculation for so many oscillations. That's the sole reason for that. So 0.1 by 128 second, and that too multiplied by 100. This. Now for case 2, delta G by G into 100 is delta L 0.1. Obviously it's centimeter. Okay, let me write centimeter by 64 centimeter plus 2 into 0.1 second divided by 64 second into 100. Okay, next it is delta G by G into 100, that is 0.1 centimeter divided by this 20 centimeter. See, observation 3, it is 20 centimeter and time is 36. Okay, 20 centimeter plus 2 into 0.1 second divided by 36 second into 100. Now here I think the full question is not that, it was asked that which one is lesser or which one is greater. By the way, you can calculate it from here and evaluate.